Thank you. Thank you very much for having me here, the wonderful folks who run the conference. I really appreciate it. Thanks to you all for being here. I want to talk about something we deal with every single day in our work. What really makes our lives really difficult? I want to talk about complexity. But before I do that, when I was a child, I used to tell a lot of scary stories. Now I just talk about programming, and that does it. And it turns out that we have a very challenging life to live. We deal with complexity every single day at work, and this is what we have to tackle. And we have all the good efforts we put in. We want to be successful. We want to deliver applications, but the things that we create today ends up really affecting what we can do tomorrow. And that's what I want to talk about today is what are the things that lead to complexity and maybe how we can actually minimize such complexity in our programming life that we do. And what I want to do is to identify certain things I've come to experience. This is more of a sharing of my experience through my projects that I worked on for clients over the years. And if you ask me what do I do for a living, I'll be honest about it. I actually do more of code removal than code adding these days. I go to clients and I find that they have written way too much code than they really need. And oftentimes when I leave, they actually end up having a lot less code than when I walked in. And one of the things I fear the most is unnecessary complexity and accidental complexity that people bring into the applications. Well, one of the things we often hear about constantly is that the only constant is change. But we live in a world of agile development these days. So I want to ask the question, what is really agile development? Well, agile development really, agility is all about our ability to adapt to change. That's what we really are looking for. And adaptability is really the key in this case. Well, if adaptability is really important, we want to do things that make it easy for us to adapt. But what do things really make it hard for us to adapt is the question we need to really ask. And it turns out complexity makes it really hard to adapt to change. And so if we really want to adapt in the future, one of the things we have to really look for is to find and remove these kinds of complexity that make it really hard to adapt as we move forward. Because the change is the only constant, well, then we want to really be able to afford the change, embrace the change, even late in the game, but how do we do that? Well, it turns out we cannot be naive about it. We need to really understand that the world we live in is not something that's going to be trivial. We work with applications that are significant. We work with applications that are in the banking industry. We work in applications that are dealing with satellites. We work with applications that deal with transportation. Imagine every single aspect of human life is now touched by computer programs. I don't think I ever thought about it that way when I started programming, but to realize one day that what you do affects every single aspect of human life on Earth is just pretty amazing for us to be in this field. But it turns out that system design is complicated by nature. Well, there are things that are going to be complicated no matter what we try. When you deal with your business, the things they want your application to do, and the minute you think you got a grasp of it, they come back and tell you that's not it, and they tell you more that you have to deal with. And you have to constantly deal with this. This is complicated business we have to deal with. But notice that the applications we develop are already complicated, but unfortunately, really sadly though, that the complexity that we create really is what we add to this, what is already complicated. So we don't want to really add complexity to what is already complicated. We want to really minimize that. So what I want to talk about here today is how can we really, maybe do that. So I want to say that we are victims of our own complexity. So complexity often comes from the solution we create. And I want to separate between the complicated systems we deal with and the complexity that we introduce. And if we can be smart about it and eliminate that complexity, we can do a lot better. So I want to talk about the question, what makes software complex? And every single one of this I'm going to talk about today is what I've observed in my experience working with different companies. And these are things I've kind of jotted down in memory lane over the years, and I kind of captured that in this particular talk. So let's talk about the very first thing I've taken note of, and that is moving parts. Too many moving parts make things really complex. Now, when it comes to applications, this is only getting worse by the day. Everyone wants to build microservices today, whether they want it or not. That means more moving parts to what we are building, for example. And the question is, are we really up for that complexity? Is that complexity really worth it? Is it what we really want to go after? Does it provide value? Is something we have to ask. And there's a beautiful saying by Leslie Lamport. He said, a distributed system is one in which the failure of a computer you didn't even know exists can render your own computer unusable. And this is so true in the world we live in today. He wrote this a few decades ago, but this is so true today as much as any other time. And that is one of the things we have to deal with. And like I said, with more complexity we build in, this only becomes reality. But part of what we also do is we aspire to build applications that are extensible. And I remember one particular client that I worked with that resonated really well with this problem. They wanted to build an application that was extensible. Their desire was to build this application that they can deploy for any customer, and it would look exactly what that customer wants. So in their aspiration to do this, they started configuring every single thing you can imagine. There was nothing in this application that could not be configured. So this was excessive configuration in this application. And they had way too many components and way too many layers. Not a single person could really explain how things actually worked. And when I went to work for them and I asked them, how do they use this application? And I found out that when they want to deploy this application, they would send a team of engineers who would spend their life configuring this application. They spend more time deploying than actually developing because it was so much configuration. And how did they configure? You probably know this already, right? It was configuration in XML. Now, we know one thing about configuring in XML. Configuring in XML is configuration from hell, because that's what we have to deal with. Is there anyone here who loves XML? Not a single hand went up. Here's my understanding of what XML is. And this is my observation from my own use of XML over the years. And I come to realize that XML is like human. It's really cute when it's small and gets very annoying as it gets bigger. And this is something we have to deal with. And can you imagine, in this particular application, their XML configuration was so big that nobody survived it. And they have to spend months on end to configure this, to deploy it. And eventually, this resulted in the demise of the company, actually, because when they could be really responding to change early on, it came to a point where they couldn't respond to change anymore so easily because their engineers got sucked into this XML, never came out alive. And that is one of the things we have to keep in mind is we don't want to get into a configuration hell. We want extensibility, but we have to really look at the cost of how much effort it takes to really make things extensible. That becomes really important as well. So the application becomes brittle. It becomes really error-prone. You change something here and something breaks over there. It's really hard to deploy, very hard to reason. When you ask people, how does it work, they're not able to describe to you how it works. And one of the things I often look for is testability. Here's an early sign of warning. If an application is really hard to test, that's a disaster in the making in general. So I would always look for how easy it is to test this application during development, and that's a sign during production as well. So one of the things to really ask for is, what are your moving parts? The more the moving parts in your application, the harder it is to maintain the application as well. The next thing I want to talk about here is invisible changes. And I'm a little bit bitter about it even today, because where I came across this was a team contacted me and said, we need your help. Could you please take this C++ code and rewrite it using Spark for us? The logical thing I should have said is no. But unfortunately, I said yes. And then they sent me the C++ code. And I started reading the C++ code. Just before I say that, let me say this. I had spent 15 years teaching C++. I have spent several years working on C++ project. I am current with the latest standards of C++. I still teach courses on C++. It's not a language that's alien to me. But I looked at this code they sent me, and to be fair, it was not a very large piece of code. only a few, several hundred lines of code. And I read through it, and I read through it, and I read through it again. And every time I read it, I felt more stupid. And I'm like, why don't I get this? Have I gotten really old for this stuff? And I'm reading it again. And something is completely illogical because the code is saying one thing and the application is doing something completely different. And I was trying to figure out, why does this code do this? And I came to realize something over time. There are two kinds of code that frustrates me a lot. The first piece of code that frustrates me is the one that doesn't work. And it's very annoying. But even more annoying is the one that works but shouldn't. And this is very painful. And this is exactly what this code was. And I'm looking at him like, why are you working? And I don't understand why this code actually works. And I'm reading it and reading it and reading it. Finally, I open up the debugger and I start stepping through the code. That's called an act of desperation, isn't it? And I come to the state of the object, and there is this innocent method which gets something. And I step over that method, and suddenly this object turns into a monster with a lot of state populated. And I'm like, damn, how did that happen? And now I'm stepping into that function. And you know how that goes. Then you step into the other function. And then deep down, like 7 levels later, I'm looking at that code and saying, rascals, why did you do this here? And they had completely manipulated the state in a place where I would least expect. And the problem here is, when you read a code like that, you feel so cheated as a programmer. Because you're like, why didn't you just make this obvious to me? Because I spent the last few hours trying to understand how this code is working. And if this was obvious, I wouldn't have spent this much time. And that is one of the things to really ask the question. So my observation at that point is, don't sneak around and change state. So I want this to be extremely obvious to the reader. One of the things we need to keep in mind is, we write code once, but we read it several times. It's no point in optimizing the code for writing when the real cost is in reading the code. So I always ask the question, what is the reader of the code? What is their mindset? What are they looking at? What is their chain of thought? And we want to be able to lead the chain of thought to the reader of the code. That is absolutely important. So if we sneak around and change the code, and the state in the code, it becomes really hard to maintain it. So, and what is the result of that? The result of it is lost time. Lost time is lost productivity. Lost time is lost money for projects. And so what did I do in this particular project? I'm not even kidding with you. I started reading the code again and again and again, and then I realized I will never be smart to read this code. So I wrote them an email and said, could you do me a favor? This code you sent me, is there a research paper that this was based on? And they said, oh, of course. And they sent me a link to the research paper. I deleted the code, honestly. I read the research paper, wrote the code in Spark, sent them to this and said, here you go, it works in Spark, and don't ever call me again. And the point really is, it's not enough wasted time, and this becomes really frustrating. We have to really ask the question, how much time and money are we wasting on stuff like this? So let's avoid invisible changes. So too many moving parts, invisible changes we talked about. The next thing I want to talk about here is uncontrolled mutability. Now, we all have done mutability in code. In Java, it was a way of life for us to do mutability. But unfortunately, as years go by, I realize the more we mutate, the really harder it is to understand what the code is actually doing. And this becomes really hard to explain and reason with the code. I remember this day when a programmer walked into my office and said, hey, here's a function I wrote. It doesn't work. Can you help me? And I quickly eyeballed the code and said, if you send this input, it should give you this output. He said, yeah, I know, right? It doesn't. So we both are reading through it like crazy people. And after a few minutes, I looked at it and said, hey, did you mean to change the input variable in line number 7? He got up for a minute, stared at me, and he said, I'm stupid, and he walked away. And this is really hard because it's really hard to even think that you're modifying a variable at that point in the code. So mutability needs company. It often hangs around with bugs. And so there is a correlation between the amount of error we introduce in the code and the amount of mutability that we end up having in the code. In fact, I'm going to go to the extreme and say that mutability actually causes brain damage. And this is something that's going to be really hard for us to work with as time goes on projects. So the less we do mutability, the better it is for all of us. But this is one thing that we all realize. Let's, for a minute, think about the life of a programmer, if you will. This is what we do, isn't it? When your code has all this state transition in it, what do you normally do? You're sitting there and staring at your code, but when you're doing this, you have built this entire model and the current state in your mind. And as you're walking through the next code, you are detaching this and attaching to this other object. And you're in this harmony at this point. And when you're doing this, suddenly somebody opens the door and asks you the question, do you want to go for lunch? And then you just stare at them. And you're like, what? And they're asking you, do you want to go for lunch? And you're like, sorry? And they're like, you're weird. And they walk away. And then they come back and say, are you okay? You're like, no, look what you did. And now you're putting this back together because they completely shattered the state. And now it's going to take you 30 minutes to build that state back in your mind. Only programmers understand this, isn't it? Because when you're looking through the window, you're not looking through the window. You are just adjusting the state in your mind. It's so fragile. And anybody ever asks you a question, it's completely shattered. And then they look at us and say, you people are antisocial. They just don't get it. And I'll tell you, the best money that I ever paid in my life, ever hands down, was when I went with my wife to watch the movie Social Network. This was worth it. I didn't know this coming. I was right there sitting in the theater watching the movie, and there was one scene, she literally screamed right in the middle of the movie and said, oh my gosh, I get it. I'm like, gosh, what did you get? And she's like, I get this. And here's the scene that she got it in this scene. So I'll share the scene here with you. Hopefully the audio works. So this is the scene right in the middle of the movie. So here we go. The audio is not working. Can we try the audio again, please? That audio is working. Let me try this. Nope. It's through here?
No.
Oh, I need to change the audio setting? I'll tell you what every programmer says at this point. It worked before. It truly did. So let's see. It says headphone. I'll change it to that and see if that works. All right. Let's try this again. Here we go. All right. It doesn't want to work. Let's try this one more time. Otherwise, I'll recite for you what it's doing. So that seems to be output, yes. Yeah, it is an HDMI. Let's change it to a headphone and see. Let's try that again. There you go. That's awesome, isn't it? Okay. All right. So let's do this again.
I didn't know we had a doorbell.
Andrew, get the door!
No, he's wired in. That's gonna cut into security deposit. Andrew.
Knock down.
Good boy. I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
So that's what I'm talking about. That particular scene is when she screamed and said, oh my gosh, I get it. I'm like, what are you getting? And she said, I know why you do this. When I talk to you, you're wired in. I'm like, take my money. This is amazing. when the family gets it. And a week later, I was working in the kitchen, and one of my kids came to me and wanted to have a question. Said, Daddy, and my wife said, don't talk to Daddy right now. He's wired in. And I am like, yes, this is amazing. And that's one thing I really realized, that when people understand, when you're staring at a computer or staring through the window, it doesn't mean you're staring, you're not doing anything. You are managing your state in your mind. And this is one thing I would say, is I've been a programmer longer than I've been married. And when I got married, I was a little fearful, because I feared I have to choose between being a programmer and being married. Thankfully, I didn't have to do that, for two reasons. One, my wife is very kind. Second, she understands programming. I didn't say she understands me. She understands programming. And this is one thing I learned very early on in my marriage. There was one day she came to me and she said, I want to go out. Do you want to come with me? I said, oh, I'll be with you in about 5 minutes. And she picked up the key and left. And she came back after a little bit, and I told her, I'm really sorry, but I told you I'll be with you in 5 minutes. I'm a little surprised you didn't care and you just left. And she came to me and said, sweetie, you don't know this. Let me tell you this for once. When you say 5 minutes, it is 7 hours in human time. And that's when I understood that we have a different concept of time. Remember when the boss comes to you and says, how's it going? It's almost done. We say this all the time, isn't it? It's almost done. So we have a very different perception of what time really is. I was here in Wrocław, and the user group folks invited me, and I had a wonderful time speaking there. And then they said, hey, here's a little church. There's a staircase that takes you up there. Do you want to walk with me? And I said, sure, but how many stairs are there? Oh, only 90. And I started walking. You know what? It was not 90. And I almost, after that I said, how many more? Just a little bit, almost there, they said. And as I kept walking, I stopped and said, damn, you guys are programmers. How did I come to accept your estimation? And this is the problem, right? So I'm very careful these days. But one thing I realized from being in the family is this. To me, this is one of my aha moments, is that happiness is when the world understands programmers. When your family understands what you do. And I tell my family always, I'm sitting here in the kitchen, I'm working. You can talk all you want, just don't expect me to answer back. And that's when you really know, because all this is kind of getting deflected and your thought process is just churning through it. And so I realized that mutability makes it really hard for us to reason. And we need to really reduce mutability as much as we can, because it becomes really expensive for us to maintain the code as well. And that's the next thing I would really like to do, is to reduce mutability in our code. Well, moving a little forward, lack of cohesion is another problem. So complexity comes from lack of cohesion. What is cohesion? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. But a code is not cohesive. That means it does several things. And when a code does several things, it's really more complex for us to understand, and that becomes really hard to maintain. That's complexity that we have to deal with. Well, when it comes to cohesion, like things are together, unlike things are apart. And of course, the code is focused. The reason for this, of course, is we are minimizing the frequency of change. So as much as we can, we should really try to make the code more cohesive. I was in Canada for speaking at a conference entirely run by students who go to universities over there. And they had a competition that year where they wanted the students to build different things with Legos. And the options were almost endless. And I began to realize how beautiful this is in terms of modularity and abstraction. And what if the software we create can as well be so concise and cohesive? What difference would that make is something to really think about. The next thing I want to talk about is what we deal with every single day: excessive dependencies. Dependencies drag us in and beat us down. Now, dependency is unfortunately a necessary evil. We cannot develop without dependencies. but we cannot also develop with dependencies. I was talking to a team recently. They were working on a JavaScript project. And I asked the developer, how many libraries do you use on this application? I was working with them. I know what the application is doing. And in my mind, I have an estimation of what they should do. And without missing a beat, he said, oh, we use 150 libraries in this. I said, 150? He opens a dependency file and shows it to me. Sure enough, more than 150. And then I looked at him and said, why are you using that many? He kind of shrugged and said, because we found them. And this is so true, isn't it? And because we found them, sure, at least he's being honest. And this happens a lot. I've been programming for about 35 years. When I started my programming career, I lived through the days called DLL hell. And this is one of the things I tell my children. I tell them the stories of my life, how terrorful it was to work back then. And you would have to deal with the DLL hell. And in the middle of the day, somebody would say, your code doesn't work. Well, that was very helpful, thank you. Now, what doesn't work? It doesn't work. Well, that's even better. And then you go to them and say, are you using the right DLL? Yes. Where is your DLL? Here. And then after 30 minutes of wasted effort, you find out they changed the path on their machine. And that's using a wrong version of the DLL. Well, then I was so happy to move away from the DLL hell. Then I started programming in Java. The good news in Java was we dealt with jar hell. Then came along C#, I worked with assembly hell. But those things got really better as time went on. So I've had one hell of a programming career, from DLL hell to jar hell to assembly hell, but now to NPM hell. Well, this is a story I'll share with you. I was on the flight the other day, and the captain came on the speaker and said, folks, we reached our cruising altitude of 36,000 feet. Everything is going smooth. I'm turning off the seat belt. I shouldn't have done this. But I opened my laptop, and all I did was NPM install. Turbulence right away. I'm like, sorry, I didn't mean to do this. They never let me on the Wi-Fi anymore. And the point really is, this becomes horrible because it'll go with vengeance and download the entire internet for you. I was mentioning this the other day, and a developer said, oh, I don't have this problem. I said, really? How come? How do you manage your dependencies? And he said, I use Maven. How do I tell him this? You don't use Maven. Maven uses you. And the point really is that we get sucked into these dependencies, and that becomes a dependency hell that we have to live with. And this becomes horrible. And this is one of the things we fight every day constantly at work, is dealing with all these dependencies. Now, I'm not going to tell you that the past was better than the current or the future. But I'll just share with you the past that I lived through years ago, or even decades ago, I would say. And that is, dependencies usually are really hard to maintain, and we struggle with it. And dependencies become obsolete over time, and they become incompatible. But back in time, when I wanted to use a library or a framework, what would I do? I would have to go get them. Well, one of the things to consider in this case is, when it comes to these libraries and framework, you need to be very careful how you bring them in. And related to that, I'll talk about one other thing that causes these problems, like the developer who said, we found them. Well, this leads to what is called technology infatuation. This is a problem that plagues us a lot. You hear about a certain technology, and the next thing you know, you're like, oh my gosh, I should use it. And this is a really big problem because we don't know enough about it, but we feel strong that we have to have that on our project. And that becomes really a problem for us to deal with over time. So the question to really ask is this the right technology for our project? And a word I would want every one of us to really think about is this word called reversibility. So what is reversibility? Reversibility is our ability to back out of design decisions. So you make a decision today, and in 3 months you realize, you know what, that's really not a good idea. And you want to back out of the design decision you just made. And if you want to back out of the design decision, how easy or how hard is it to really make that decision? And if something is easy to reverse, I'm okay to make the decision a little lightly. If something is really hard to reverse, I want to spend more time to make that decision as well. From that point of view, I will think a little bit about library versus framework. Well, there are libraries we use, and there are frameworks that we use. What is the fundamental difference between these two when it comes to reversibility and the cost of using them, and in terms of complexity? So I will say, in the case of framework versus library, the use of a library is easier to reverse than the use of a framework. If you're using a library, you can more easily back out of it and say, I don't want to use this library anymore. And you can change to a different library. There's a cost, but it's not an overwhelming cost. When it comes to a framework, the framework calls into your code, and in turn, your code calls into a framework. So what is the way to really think about it? Well, here's a silly analogy I would use to compare libraries and framework. I'll say using a library is like dating. Using a framework is like a marriage. You don't want to be too easily getting committed to it. Well, the other day, a developer came to me and said, but, the framework I'm using, I didn't choose it. The enterprise architect decided it for my project. That's like arranged marriage. The point really is you still get dragged into it. And you want to really ask the question, is this the right choice? And one requires a greater commitment than the other, so we have to be very careful making the decision as well. So in general, I am a little bit more averse to framework. I would spend more time thinking about it and say, is this really what I should be committed to? Because it's a long haul. It's not something you can change so easily. In personal experience, the projects I have, the ones I fear the most are the ones where I'm using frameworks more than the ones where I'm using libraries, because that becomes really hard to change in the long run. So from that point of view, when I was young, when I wanted to use a library, this was time before the way we know internet as it is today. I know this is really hard for a lot of people to even think about it, especially my children. They look at me and say, what do you mean there was no internet when you were a kid? That's always hard to explain to them. In fact, the other day, somebody was asking, hey, why don't you Google for it? Well, there was no Google for us to use back then. So in other words, if I wanted to really use a product, I would read about it, come to know about it somewhere, and then you place an order for the product. And then you wait like it's eternity. And one day, honestly, there will be a tape drive that arrives at your desk. When there is a tape drive, a tape arrives at your desk. And when there's a tape drive between you and the product you want to use, you don't use that so lightly. And I've spent my youth installing products using tape drives, but today, you're out at lunch, and somebody mentions a particular package or a library. By the time you come back to your office, one of your colleagues has already downloaded it. And it's already in production on your product. And you're like, wow, how did you get to use that so quickly? And they're so proud about it. And this is dangerous precedence we are setting. And now everybody wants to develop microservices. I'm like, is this your project that's really requiring it? Everybody wants to use other libraries. Everybody wants to use something. And the question is this the right solution for us? The other day I was talking to a developer and he said, oh, our project is going to use it. I said, how do you know you need to use this? And then he looked at me and said, do me a favor. Please don't come talk to my boss. I said, why? It's because we convinced him we cannot develop the product without this particular framework. There's a name for it. It's called RDD, which stands for resume-driven development. And that's what we do quite often, is so we can put it on the resume. This is scary stuff because when I look at resumes, I often look at this and say, what is not here? Because the list is so overwhelming. They got every single library and product listed, and it directly goes to trash can, because what does that say when somebody has used 300 different libraries? That tells me they're going to come and slow my project down as well. I don't want that kind of commitment on my project. I want to deliver application pragmatically using what is necessary, not just to say, here are things. So how do we really balance this out? Well, sure, if I want to really learn about something, and I do, I want to learn about it on a side project. I'll spend my time developing that on a side project. And once I learn enough about it, I can then decide if that really makes sense or not. And if it does, only then would I bring it to my project, not otherwise. And there are so many things we should be really playing with, but not put into production. And there should be for select few things that actually go into production as a dependency in our application. But I'll share with you a really sad story related to this. And I call this the tale of infatuation. And this is really hard for me because this is something you don't want to see happen to things that are around you. You want things around you to succeed. So this was back in time years ago, and the economy was not really that good in the US, but I was really happy. I was working on a project as a consultant, and we wanted to really hire more people. So we were interviewing people to hire on the project. And as we did, we came across one developer who was just absolutely phenomenal. And my jaws were on the floor looking at this person. I'm like, wow, this guy is so knowledgeable. I really want to work with him. I was very selfish. I said, I want to work with him. I want to learn everything from him. And so the person in charge of the project, the VP of the company, came to me and said, hey, what do you think of this guy? I said, don't waste your time. Please go hire him. He's the best person we have come across. He's amazing. His knowledge is wonderful. I really want to work with him. Go hire him. He said, yeah, I understand that. What do you think of the framework he has been developing? I said, oh, that's the best framework I've ever seen. Look at all the beautiful features it contains. It's just amazing. But of course, it's not surprising. The guy is really that good. No surprise he developed this framework. I'm all for, what he has done. But anyway, don't waste your time. Go hire him. Yeah. But what do you think of us using the framework? I said, oh, whoa, step back for a minute. We got a product to release in 6 months. You don't need any frameworks right now. So can we keep our focus, please, on the project we are developing? Hire the guy, let him come on board, we'll work with him, let's develop this, let's deploy this. 6 months later, you do whatever you want to do. He said, no, but did you notice, Venkat, that this product had a distributed, persistent data store? And I said, you never used those words in one sentence ever before. Why are you saying this? He said, did you see how it has persistent messaging with fault tolerance built into it? I said, look, you never used those words also in a sentence before. You are infatuated. Please don't do this. Hire him, put him to work on the project. Here's what I'll tell you. You finish this and release in 6 months. You want to use any framework for the next version, I will be with you. Let's do this. Well, 2 weeks went by. I remember very clearly Wednesday afternoon. I'm sitting and coding away on my desk. And he literally comes over, sits on my desk. I remember that like it's yesterday. Sits on the desk and says, hey, Venkat, I got a good news for you. And I was sitting here, looked at him and said, what's up? Oh, we have hired him. And I just leaned back and said, I can't tell you how happy I am. This is the best news ever, in my opinion. We're going to have fun. This is going to be great. And the guy is amazing. And like I said, I really want to work with him because I want to learn everything from him. This is going to be really fun. So thanks for hiring him. And then he said, oh, as part of the hiring contract, we have agreed to use this framework on the product. I said, tell me you are just joking with me. Tell me you're saying this to make me angry. He said, no, this is the truth. We have agreed to use this framework. I said, well, then, I just resigned. I just quit. He said, oh, I know this is coming. I already told my boss, the minute I tell you you're going to quit. I said, at least I'm predictable. I'm so happy for that. Well, I closed my laptop. I plugged my stuff out, and I said, if you have any other project, please call me. I'll come and work with you. But this one, it's doomed. But you don't need me for this. You should run with it. How long you are going to take to finish this? Oh, 6 months. We'll be still done with it. I said, awesome. Good luck with you. And this is one of the very few days I actually went home early. I went home, my wife is like, hey, you're early. I said, yes, I quit. And she said, you quit? I was like, yeah, I quit. Well, in that case, I got some dishes for you to do. That's the way she is. And it was wonderful to doing dishes the rest of the day and the rest of the week and another 2 weeks when I had no job. And then, of course, eventually, something kind of, caught my eyes. I moved on. And I'm not kidding with you, 18 months later, my phone rings. Hello? I said, hey, Venkat. Hey, how's it going? Go ahead and say it. I'm sorry? What do you mean, go ahead and say it? Go ahead and say it. I told you so. I said, oh, no. What happened? Well, things have not gone well. We are behind schedule by at least a year. We're still trying to finish this. And after a little bit of a talk, I said, so why are you calling me? Well, I was wondering if you want to come and help us to turn this project around. I said, there's a reason I quit. And why would I want to come today? I quit when the ship was on the shore. Now you're sunk in. Why would I want to jump in and rescue you now? So never mind, sorry, not interested. 6 more months later, this is 2 years after I quit, the phone rings. Hey, what can I do for you? I know you don't want to work on this project. I'm not asking you to come and work with us. All I want you to do is come and look at the product, write an expert report on it, and you're done. You get paid for a day. I said, I can do that. So you guys are done. Absolutely. I'm like, this is awesome. And I'll come and write a report for you. No problem. It's a one-day gig. I'll be happy. And I showed up, I'm not kidding with you, 8 a.m. And he takes me into this room, closes the door, and there's a computer with a few instructions next to it. And I open up the application, and I enter a little information there, click on a search button, and I'm waiting. And I'm waiting. And 25 seconds later, something popped up on the window. And I did that again. And then I measured the time and said, it's taking 25 seconds. He said, uh-huh. I said, the speed of the computer, oh, don't even talk about it. This one is many times faster than what we can get in the field. Okay, database, don't even talk about it. This one is local. It won't be local in production. I'm trying different things. And then I started profiling the application. I'm not kidding. When I profiled it, that one click resulted in a creation of 1,864 objects. I said, did you notice that one click created 1,864 objects? He said, it's object-oriented. And I am like, okay. And then I looked around and said, I got a question for you. Where's the team? And he kind of swallowed a little deeply and he said, so what do you think of the program? I said, no. I'm asking the question, where's the team? And then he says, they fired the entire team. Well, after 2 years, they delivered something that doesn't even work. And they fired the entire team. And then I asked him, what did you ask me to come here for? He said, fix it. I said, I'm sorry, I'm a mere mortal. I'm not a magician. I want to go home. I'm not kidding with you. I was there till 10:30 in the night. He wouldn't let me go. He wanted to know what options are there to fix it. And when I left, I said, today, I'm going to leave, and I will never send you invoice for today because I like doing surgery. This is postmortem. I'm not there for that. And I walked away never to ever go back. And I went with a broken heart because these are good people. They were struggling to develop a product to survive in the business. And they want to develop an application. Technical people should have the wisdom to tell them, don't do this. And if we technical people don't have that wisdom, the business stands zero chance. And we always like to complain about management, but a lot of times we have to stand up for responsibility and say, we want to deliver this application for you, and we can't go this way because it's not going to happen. And that was a very, really sad experience for me because here's a product we were working really hard, and it completely was dead because they were infatuated. So we want to really avoid that kind of infatuation. So don't build what you can download, sure. But don't download what you do not need. So I'm very reluctant when it comes to using libraries. I'll say that very honestly. People will ask me, why don't you want to use this? It's there. And I will always ask the question, there's a cost of not using it. But there is a bigger cost of using it. And I want to know what's the cost of using it as much as the cost of not using it. Because if I end up using the wrong stuff, it costs me more in the future. It is so much easier to put that in. It is so darn difficult to take it out. So I want to be very reluctant for a good reason, because I care about technology, but I care about economics of technology even more. And the more I mature in my life, I more think about what's the cost of doing it more than how cool it is to do this. The next thing I want to talk about here is about a few accidental complexities. One of them is low level of concurrency. We see this a lot. We look at a problem and we say, hey, we can solve this problem with a pool of threads. Now we have a pool of problems to deal with. Let's look at an example of this just to get a feel for it. So here's a little piece of code, if you will. And in this piece of code, all I have here is a little nice little beautiful variable called done, which is Boolean. And notice it's a static variable right there. And I set it to false in the main. I create a new thread. And I say that the thread is running. Then I have a loop where I say not done. I increment the count right here. And then I loop through. And whenever the done is true, I will get out of the loop and I'll print exiting thread. Then after a 2-second delay, I print out setting done in main, and I set the done to true. So logically, if you eyeball the code, you're saying this is going to loop for 2 seconds. At the end of 2 seconds, it's going to print setting done to true. And then the done is set to true. It should bail out of this loop, and it should say exiting thread. Well, when I go back and run this code this time, though, notice that unfortunately in this case, it is going to, I need to save the code. So in this case, when I run this code, notice, it is going to say in main, running. 2 seconds later, it said setting done to true. But we're going to wait for a very long time, isn't it? How long? For eternity. So why doesn't this code really work? In fact, this is a beautiful code that you can torture people with. Because you can go back to this code and ask the question, if I say thread.sleep 0, can you even believe it? A sleep of 0. You're not even sleeping. But you just drop that one-liner right in here. That's all you're doing, a sleep 0. You go back and run exactly the same code. In this particular case, what is it going to do at this point? Okay, it wants to deal with the exception. Let's go ahead and deal with that real quick. So we'll go ahead and say, in this case, try. And then we'll put a little catch right here. And of course, in this case, exception. And we'll just put a little sleep 0. That's all we are providing. Run the code this time. And the very exact code now is terminating. Now, how do you explain this to a developer? Why putting a sleep 0 works? Whereas when you don't put a sleep, it doesn't really terminate. Well, this is the beauty of the concurrency library provided in Java. Remember watching Harry Potter? What was so wonderful about Harry Potter? What is wonderful about Harry Potter was there were 7 Horcruxes. You don't know where Voldemort put it. And Harry had to find it. What's even worse is Harry says, I don't know what we are looking for, but look for it. That's what made you sit in the edge and watch this movie. Can you imagine Harry Potter if they started the movie saying, here's a list of documented Horcruxes, and here's exactly where they are placed? You would have left the movie early, right? What fun is that? Well, Java has 7 Horcruxes. These Horcruxes cross the memory barrier. One of them is the sleep. When you put the sleep, the code behaves very different. It doesn't matter whether you really sleep or not, because the sleep makes the memory cross the memory barrier. Similarly, when you do synchronize, you cross the memory barrier twice. When you use a volatile variable, whether you read it or write it, you cross the memory barrier. And when you call a method with a join, when you call a method with a wait. And so these are built into the language, but we didn't really say, hey, these are the methods explicitly to cross the memory barrier. You just had to know it. You had to play that Harry Potter. And that's what makes it really hard for us, because we have to deal with that kind of complexity in programming, and that makes life really hard. So a key design skill we need to develop is the ability to discern accidental complexity from inherent complexity. So if as programmers we can sit down and say, that is an inherent complexity, that one is accidental, don't do it, I think we can come out winning really by doing that. Well, the next thing I'll talk about here is another complexity, accidental complexity, which is imperative style of programming. Most of us have done imperative style of programming. I spent my youth programming in imperative style. That's the one I'm most familiar with. But I realized over time that it is also more complex. So I'm going to say in here, imperative code is packed with accidental complexity. On the other hand, declarative code has less complexity. But let's look at an example of the code just to see how that is true. So here's a little code I have. And in this code, notice, is prime tells us whether a number is prime or not. And the main simply has a random value n and k, but I want to call the compute method. What does the compute method do? The compute method says, return the value for n and k. Well, what is the value I'm going to return? Find the total of the square root of the first k prime numbers that start with n. Let's write this code in imperative style just to get a feel for it. So what would you do? Double result is equal to 0. That's the very first step. Return the result. This is called hope, isn't it? Then what do? Int index is equal to n, and then you say int count is equal to 0. So what did we do so far? Nothing useful, right? All we did was we created a bunch of garbage variables. Then you say while count is less than k, and at this point you stop everything and ask the question, is it less than or less than or equal to? Do you ever ask that question? Every single time. When new programmers come around and ask me, what is the symbol? I tell them, that's the international symbol for confusion. Because everybody stops there and says, huh? And we don't know. And then what do? Then you say, in this case, you say if index, well, in this case, if is prime of index. If it is really a prime number, what am I going to do? Result plus equal to math dot, and I'm going to say, in this case, square root of the value index. Well, okay, is that done really? You say, wait, no, you need to increment the count. So increment the count. Is it done? Well, you need to increment the index. Okay, incremented the index. Is this correct? No, what's wrong? You say it should be outside, so I'll move it outside. Is it correct now? You say, no, this must be inside. How do you feel about that? Right? One should be inside, one should be outside. And then when you run the code, it produces some result. But look at the complexity of this code. Well, okay, this is a code you can write, but it is a lot more effort to read it. Because you got to read through and hold all that state change in your mind. And that is a lot of effort. If you're dealing with a code like this, what's going to happen? Well, you're staring at this code without going to lunch. Your business analyst comes to you and says, hey, how's it going? Your response normally is, that's what I'm trying to figure out, you shut up. And that's how we feel about code like this, right? It makes us very irritable. Well, thankfully, we don't have to do it this way. What if we can say return stream.iterate, and I'm going to say, starting with the value n, let's create an infinite stream on this, and we'll do a filter. And in this case, we will simply call the sample, this current class, and we'll call the method called isPrime. But we will perform a map to double on this, and we will ask it to find the math square root of those values. But then we say dot limit, and we simply ask it to limit it to k values, and then you perform the sum operation in the end, and then you return the result of that particular call. And if you notice over here, this code begins to read like the problem statement. You didn't have to write that much code. And you can logically read the code from top to bottom, one single pass, and say, given all the numbers that start from n, give me all the prime numbers, but give me the square root of them, and limit them, and return the sum. That becomes a lot easier for us to work with. So declarative style really helps us to focus on the problem instead of losing track of what we're doing by focusing on the how. The last thing I want to talk about here is called entwinement. Entwinement, everybody falls into this trap. Even the people who wrote the JDK did. So what is entwinement? Entwinement is where you take two concepts that are orthogonal and not related to each other, and you put them together. A really good example of this is in how we dealt with garbage collection. Well, in the case of Java, garbage collection is automatic. But we know that garbage collection is not instantaneous. When Java introduced garbage collection as being automatic, we were like, yay, this is great, but How do we deal with external resources? Well, unfortunately, though, external resources need to be cleaned up properly and promptly. Well, their initial suggestion was, hey, why don't we provide you a finalized method? That was a bad idea. Why? Because garbage collection is automatic, deals with main memory. It is something that will happen on its own pace. And when the garbage collection happens, finalize is called. When the finalize is called, we will clean up external resources. Wait, external resource cleanup is completely independent of memory cleanup. You can clean up the memory anytime you want to clean up, but I want to manage the external resources more deterministically. So this is a really good example of entwinement. In fact, this hurts us a lot. In our own applications, we do this quite often and get into trouble with this. In fact, it's so prevalent, Rich Hickey coined a term for it. He calls this complecting. He says complecting things is the source of complexity, he says. And we do this, a lot of this in our own code. We take two different things and put them together, and we suffer the consequence of the entwinement. And we should really have the wisdom to say, these are independent and keep them away from each other. So we talked about these 9 different things that cause complexity into our applications. Too many moving parts, invisible changes, uncontrolled mutability, lack of cohesion, excessive dependencies, technology infatuation, low level of concurrency, and of course, low level use of concurrency API, I should say, an imperative style of programming, and entwinement. And we fall trapped to any of these, or naturally, unfortunately, more of these, and we deal with it. I would say one of the things we should really do as we mature as developers is we should learn to deal with complexity and have the wisdom to minimize it. And this is what I do when I go to projects. I try to identify complexity and say, can we get rid of these? Because these are hurting you on your project. These are not things you need to be carrying with you. So I'm going to finally say a maintainable code is a gift we can give ourselves for the future. And when we create a maintainable code, our future will come and thank us. And so we should really strive really hard to reduce the complexity so we can make the code more maintainable in the future. Hope that was useful. Thank you.